In this video, I break down the 6 key differences between professional software engineers and students that aspire to become software engineers, so you can use the knowledge to level up and become a better candidate on the job market. Hey, my name is Khan. I'm currently a software engineer at a startup, and I've worked for companies like Sony and Google. Not too long ago, about 6 years ago, I was an eager aspiring software developer looking to break into the industry. And from my experience, it's easy to fall into the trap that there is some magical project experience that will help you land your first job. And while it's true that projects, in the sense of code you write that is ultimately usable by people, is how you gain practical application of what you learn, learning projects are often created in a contrived way that limits the valuable learning lessons you can walk away from building stuff. This video is about these key differences between the projects that professional software engineers work on for a living versus what students will typically experience in their learning. I want you to use this information to level up your projects so that they can become worthy of attention to someone who might be looking at your resume. Okay, let's dive in. Difference number 1 is experience and skill level. Students often work on classroom and personal projects and simulated environments. Building stuff is how you apply your learning, so that's a great start. However, I would classify such experiences as limited practical experience because they often end up with undeveloped products, with the focus being on understanding concepts, basic application, and exposure to a specific technology. Professionals, on the other hand, often work on multiple projects, apps, or varying contexts, with each one solving a specific problem for a business. The need to solve a specific problem is what drives all decision making, and the work often requires specialized skills in a relevant domain of software engineering, such as front-end, back-end, system design, or more. Their skills are honed through practical application and continuous learning by repeatedly addressing different business needs. In order to get your personal projects to this next level, here are a few things you should focus on. Number 1, actually solve a real problem. It doesn't need to be a unique or novel solution to a problem. It just needs to solve a problem, even if that means there are better alternatives already on the market. Number 2 is to ship it, so it's actually usable. Number 3 is to get feedback from the people you're trying to serve. Yeah, that means you'll have to put in some effort into marketing the thing and letting others know about it. Number 4 is to iterate on the feedback and improve the application. This process will teach you by framing your project's experience in the context of an applicable problem that solves a need in the real world. And while this is still not the same exact thing as being a paid professional on a team of software engineers, the fundamentals of building for a real need is there. And you'll immediately feel a big difference in expectations, accountability, and professionalism that you have to exhibit in order to actually deliver something of use to other people. You want your portfolio to actually be a reputable body of work. That's the only way that you're gonna get people to turn their heads in this crowded market of junior talent trying to break into industry. Difference number 2 is scope of knowledge. Students often touch on many concepts and their understanding is relatively broad and shallow. That's not to say there's anything wrong with this. This is the reality of how anyone gets started in any industry. Hardly ever will a student be exposed to the opportunities and business demands that require deeper, intimate knowledge of a specific topic. Professionals in industry, on the other hand, face deeper problems that need a unique solution for a company in a specific situation, making that professional maybe one of 10,000 people, or one of 1,000 people, or maybe even less, to have really tackled that kind of problem, especially when accounting for the specific context. This is the key difference that I see when tutoring students and working with professionals. Professionals can recount a few key specific experiences that were particularly pernicious problems that taught them valuable lessons. Students, on the other hand, will be able to explain the exposure that they've had through a variety of topics and walk through basic applications of those topics through the apps that they've built, but it ends there. Now, there is nothing wrong with being where a student is at. It's perfectly reasonable that a student hasn't been forced to face deep technical challenges. My point, however, is that if you want to break into industry more easily, work to create more of those opportunities that require you to learn deeply about a specific topic, preferably one that you care to learn about and one that aligns with the kind of job you eventually want. Here's the truth. The overall pattern to getting hired is actually pretty simple. The more challenging and interesting problems you've solved, the better your chances of getting hired. That's it. Now, that's not to say that there are other factors that matter. There are plenty of other things, but I think this is a general pattern that you can rely on to be true. Keep working towards solving interesting and challenging problems, and don't stop. Difference number 3 is diverse responsibilities. Students are primarily focused on learning, completing academic projects, and passing exams. Some of those projects might even be collaborative in nature. And that's a great start because we can all use social accountability to help keep us on track. We don't want to let our peers down or not meet the expectations of our professors or instructors at a coding bootcamp. In the real world though, you get minimal social accountability from work. Generally speaking, the bar for the minimum amount of work that you have to do to get by is actually pretty low. But doing the minimum to barely get by is not really how you thrive and make a dent with whatever you're working on, especially if you're trying to get ahead as someone trying to break into industry. Professional software engineers take on challenging tasks involving designing systems, writing and testing performant code, understanding and improving legacy systems, managing projects and team members, and collaborating with non-engineering stakeholders. Our work is a lot more than just learning to code and building features. There's a lot of company-specific interpersonal dynamics and system constraints that we have to navigate on top of actually being a versatile programmer. Difference number 4 is stakes. Students are encouraged to explore, mess stuff up in the name of learning, and build things for the sake of learning, not for the sake of being used. Professional engineers, on the other hand, are expected to deliver working implementations to complicated problems to meet the needs of the business. Mistakes can have severe consequences. I remember when I was at Google, there was one bad change that made it into the Google Auth system by one software engineer that caused an outage to the entire Auth system for about 45 minutes or so. The entire Auth system for Google is not just a big deal. It's a colossal failure for Google. Every single app that integrates with Google's OAuth system, which is basically anything that requires authentication and that's built on top of the Google APIs, and a majority of Google's flagship products like Gmail, Google Calendar, Google Meet, Google Drive, and everything else under the sun was affected by this one outage. This is not necessarily a failure on the part of the employee, but of Google as a software company with high expectations of software quality. Professional software engineers spend a lot of time breaking down why things failed and iterating on that real-world feedback to put in place resilient workflows, processes, and systems to mitigate future risks. Our work is often about removing the possibility of human error. This is a class of problem that students simply never really have to face when building projects for learning. If you're an aspiring software engineer looking to build strong portfolio projects, be sure to do the thought exercise of how to mitigate risks in your code, testing, and system design to help highlight your engineering decision-making chops. I promise, this level of thinking and foresight will come in handy in your interviews and on the job. Difference number 5 is integration complexity. Student projects typically have a predictable set of integrations. Maybe you integrate with Twilio for SMS notifications. Maybe you use Mailgun or SendGrid to handle email notifications. Maybe you use Google Maps to render a map for your application. But in the real world, as a software engineer, you have to integrate with a huge variety of tools in order to make a useful piece of software, possibly including things like server logging APIs, product analytics APIs, monitoring and crash detection APIs, marketing related APIs, payment processing APIs, feature flagging APIs, and the list goes on. Moreover, you also need to integrate a system onto itself. Things have to be backwards compatible. You have to code to re-implement features to match the requirements of existing software. We swap out parts of legacy code, one piece at a time, making sure each change we make can be released without introducing breakages. This is arguably one of the most difficult, tedious parts of our job. The care we have to put into understanding how a system currently behaves is more difficult than we get credit for. Difference number 6 is security. Students never really have to concern themselves with security because their projects are created for the purpose of learning, not to be shipped to the real world. This is probably fine at the start, since concerning yourself with security as a developer trying to build their first full stack app is not the best use of your time. Learning about security starts to make more sense once you have the fundamentals of building apps down. As a professional software engineer, security and abusive users are always a major concern. The software we make if actually used by real users, will eventually be abused if abusable. That means every loophole and every weakness in the system needs to be examined. Even if the app doesn't have many users, if it has users, and especially if those users are storing sensitive data into our systems, you can bet that someone will eventually look for a vulnerability. If you're an aspiring developer and have built a few full stack projects but haven't thought too much about security yet, it's time you expose yourself to security principles like one-way hashing of passwords, encrypted connections, cross-site scripting attacks, SQL injection, and how authentication generally works. Going deep into how you went about solving for security loopholes makes for great talking points to other strong engineers. Okay, so those are the 6 key differences between professional software engineers and students learning to code. Let me know what you thought about this video down below in the comments, or if you have any questions. I'd be happy to give you my 2 cents on whatever's on your mind. If you found this helpful, I'd love it if you liked and subscribed to the channel. And if you want more content about coding and becoming a software engineer, be sure to subscribe to my newsletter, thecommit.dev. I share weekly insights about how to be an effective programmer and a high-performing individual. I'll leave a link to it in the video description. If you've been a regular subscriber and make it to the end of these videos, I just want to take a moment to say thank you and that I really appreciate all the feedback that you leave me. I make these videos for eager learners just like yourself. Okay, thanks for watching, and that's it for today, and I'll see you in the next video. Bye-bye.